plants, I arrived in Wisconsin at the same time that Nina returned to Wisconsin in retirement, and as a wildlife person who, like Nina, has been a lifelong keeper of phenological records, in my case of birds, Nina and I complemented each other very nicely, so I added lots of observations of birds. And for example, resident birds that are here all year round, when you compare the means at the shack, the mean in all those time was February 27th for cardinals giving their first territorial song. In Nina's data, February 15th. So resident birds do advance. The same is true of short distance migrants, things like robins that really only go a few hundred miles south. And of course, with our warm winters now, many of them don't even leave at all. But in all those time, the arrival of robins, the harbingers of spring, on March 19th. In the more recent data, the average was March 5th. That's in contrast, though, to long-distance migrants, the birds that go all the way down to the tropics for the winter. So wood thrushes, a close relative, obviously, of the robin, is one of those species that doesn't seem to show any variation at all. They are still arriving pretty much at the same time, so that in all those time, the average was May 8th, the average in recent times, May 5th, for the arrival of wood thrushes. And that makes sense, because they're down in the tropics, they have absolutely no way of knowing what the spring temperatures are in Wisconsin. They are responding to photoperiod. They are initiating their migration based on daylight. And that is consistent from year to year. We haven't figured out how to nest that up yet. Maybe we'll get around to that sooner or later. But it's very consistent, and not surprisingly, they are very consistent in their arrival. So in view of the heated arguments over interpreting phenological data in light of climate change, I decided to revisit the Leopold data set and do a much more sophisticated analysis of the data that would try to remove some of the criticism of the earlier paper. And remember, the comparisons, Leopold pointed out, the comparisons can be really tricky when you're dealing with different data sets, especially if there were any biases involved. And we wanted to go back and look at the Leopold data set to see whether there were any systematic biases that might have influenced the interpretation of the data. And fortunately, the Leopold data set is ideal for doing this because of those meticulous journals. Everything about how the data was recorded, all of the observations are there. And you can go back and really look in detail to look for any biases that might exist. So I'm going to look at one of them tonight, and that's the influence of observation intervals. And for example, if you only make your observations on weekends, the first event might have happened on Monday, but you wouldn't see it till Saturday. And if you were consistently a weekend naturalist, you would have introduced a systematic bias in that your observations were almost always going to be later than the actual event. So, on the other hand, if you're out there every day making your observations, you aren't likely to be as biased in the date that you report. So we wanted to look at this because this is very easy to correct for in the data. So, for example, if we look at the observations that Leopold and the family made at the shack in the 30s and 40s, they were made on weekends and holidays. Whereas his students were out at the University of Wisconsin Arboretum every day. So the comparison of the dates at the shack and the dates at the Arboretum were definitely influenced by a bias. The observations at the shack in the 30s and 40s were on weekends and holidays, whereas Nina's observations, every day, she lived there. She was out every day keeping these records. So once again, there is a bias in the earlier data. It makes those dates appear to be later than they actually are. Also, when we went back through Leopold's journals, we discovered, not surprisingly, that they didn't visit the shack as frequently early in the spring as they did later in the spring when the weather got better. So they averaged 10.5 days between visits in March and April, but only 5.8 days between visits in May and June. On the other hand, Nina's observations were made every day. So there was an extreme bias in the early spring data, which would make those early spring events seem as though they were much later than they actually were. So some of the biases are obviously there, and because of the meticulous journals, we could go back and we could correct for them. So we needed to go back and correct them. The way that we decided to correct them after trying a number of different approaches was probably the simplest one, and that was to assume if Aldo and the family were there only on weekends and they observed something on a Saturday, on average, it probably occurred on a Wednesday, the middle of the gap between their observations. So we went back and we corrected the data. I had a funny story. All of Leopold's journals are now online. You can go and look at them. So I hired an undergraduate who had worked with me on projects like this in the past, and I said, Jenny, I need for you to go into the online archives, and I want you to simply record the dates on which the Leopold family was at the shack so that I could do these corrections. And I said, it'll probably just take you a week or so to do. So a week, 2 weeks, 3 weeks. Finally, I'm getting kind of desperate because I was supposed to give a paper on this at a meeting. And I said, Jenny, you know, what's holding you up? I really need this information. And she said, oh, she said, I'm really sorry. She said, I couldn't go through and just record the dates. She said, I read it all. So I think she's probably the only person outside of Aldo Leopold who's read those journals cover to cover.